Good morning all. Welcome back to the machine learning module 1 class. To continue with design issues, in earlier class we have discussed about the rest of out of the 5 designing issues. First one was with respect to choosing the training experience, and second one was with respect to choosing the target function. Third one is choosing a representation for the target function. Fourth, choosing a function approximation algorithm, and fifth, estimating the training values with sixth one is the final design. Today the last design issue is final design. The final design of a checkers learning system can be described in 4 distinctive program modules that represents a central components in a learning system. Say for example, performance system, critic, generalizer, and experiment generator. These are the 4 modules which will represent the learning system of a checkers module. Say in performance system there will be a solution trace of game history you should go with, and in the critic you will be checking with the training examples, and you will go to generalizer and you will go with the hypothesis, and finally you will go for the experiment generator and you will go with the initiation of the game board, right. So now what is performance system? So the performance system is the module where we must solve the given problem. That means we need to perform the task by using the learn target function or target functions. It takes an instance like a new problem or a new game as an input, which produces a solution, right. The trace of that solution you call it as an history or game history. That itself will be the output. So what will be the next step after performance system will be the critic. Critic means it is the analyzing part. So analysis will take the input from the history. So after you go through the game history, then that will be the input and you do the critic or analysis. So or else it is called as tracing the game, and it produces an output for setting up the training examples for the target function. That means it will take the examples or you call it as training examples for the target function from the history of the game. Next, it will be passed on to the generalizer module. The generalizer takes as an input for training examples and produces an output called as something called as hypothesis V. That is the estimation of the target function. So it will generalize from the specific training examples to hypothesizing a general function that covers these examples and cases beyond the training examples. So hypothesization will be done after the generalizer. And last module is the experiment generator. It takes the input from the current hypothesis and it will be in the form of output of a new problem, or it will be initiated to a new game board for the performance system to explore. And its role is to pick the new practice problems that will maximize the learning rate of the overall system. So a new problem will be always initiated on the board, and it will be practiced more number of times, so that maximum number of learning rate will be increased overall during the learning system. Next, we need to determine the target function, and we need to represent the target function with respect to the training examples. So what we are supposed to do is we need to determine the type of the training examples, or you call it as experience. And next you need to determine the target function. So once you determine the target function, obviously then the determination of the representation of a learned function should be represented. That means representation of the learned function. Then after the representation of the learned function, then obviously you will come down to the learning algorithm. That is nothing but determining the learned algorithm. Now, how do you go from this determining the type of the training examples is by game experts or you call it as self gaming or playing against self, or you have a number of correct moves that you will make while you are playing the checkers board. That will give you the target function. After you reach the, or you will be determining the target function, then you need to determine the representation of the learned function. So from target function you will go with the board move whatever you will make and the board value whatever you will set with. So the board move whatever you will be making or the board value whatever you will be setting will represent the learned function. Now from learned function it will be determined with, or you will be deriving a learning algorithm. So you will determine a learning algorithm from the representation of the learned function through a linear function or a polynomial, or you call it as artificial neural networks. Next, what you will be doing after learned algorithm, finally after the learned algorithm, then you will say you will be having a design, or a complete design will be done based on a linear programming or based on the gradient descent, etc. So this is how a system will be complete and final design will be achieved. That means the design issues will be starting from the training experience, a target function, representation of the target function, estimation or the approximation of the algorithm and estimation of the training values, and the final design will be put together with respect to the determination of the training experience and determination of the target function through which it will be represented by a learning function, and finally you will be determining the learning algorithm. So that learning algorithm will be the end result of getting a design. Meanwhile, you will be having the various means to achieve each step by gaming expert or self gaming, or else number of correct moves what you will make, or board moves or board values that will be represented from determining the target function to representation of the learned function, and from representation of the learned function to determine the learning algorithm you might use linear function or polynomial function or artificial neural networks and so on. Now the perspectives and issues of the machine learning which lies here are like you need to answer a few more questions when we go with the concepts of machine learning, like what algorithm exists for learning general target functions from specific training example, or which algorithm performs best for which type of problems and representations, or how many training data is sufficient, or else something like which type of problems and representations will be best suited for which type of algorithms, when and how can prior knowledge held by learner can guide the process for generalizing the examples, or how to generalize the examples, can prior knowledge will be helpful for approximate correction, or approximately whether it will be correct. Then what is the best strategy to choose the useful training experience, and so on. And what is the best way to reduce the learning task, right? So one or more function approximation of the problems will be there, and you need to check that, okay, which one is the best, or you need to choose which one will be the best algorithm for that. Then how can a learner will make the automatically representation to be improved for learning the target function. These are all the few issues which will be there in the designing of a machine learning. Say with respect to all these 6, these will be more of the questions which will come in machine learning. This will be a particular topic which we have talked so far in module 1 of machine learning. To continue with the next topic, that is called as concept learning. Concept learning, or you say inferring of a Boolean valued function from the training examples of its inputs and outputs, or else you can call it as whenever you have an input and output of the training value, then you should be having a Boolean valued inference. Inference is nothing but an number or a value what you will be giving it as an instance. Say for example, there will be few categories like bird or birds, car, etc. And there will be few situations which we could study in order to pass an examination or in order to pass a test. There will be a situation like, okay, examination is there, so we need to study for passing the examination. Say something like that, we have the Boolean function which will be inferred as, say, true or false. Say true value will be representing birds and false value will be representing say animals. So for both animals and birds we have inferring a Boolean value in the form of true and false. True means, say for example 1, false means 0. So 1 is also a value and 0 is also a value. 1 will be representing the birds as true and 0 will be representing animals as false. It doesn't mean that birds are false. Birds are true at the inference value 1, whereas animals are also false with the inference value 0. Right? This is how we will learn the few concepts. So learning involves like acquiring general concepts from specific training examples, and those examples will be like general categories. So when we talk about the cars or birds or animals or passing an examination or whatever it might be, it is a concept where we need to learn how it can be done using a inference value of a Boolean valued function. For that, those training examples will be taken from the input and output. Now it will be represented in a tabular form, like say for example we can take an example of playing the water sport, or say for example you have water sport in the sense you want to go and swim. So when do you go for swimming? So if you consider what is the best time to go and swim, we generally think of going for swimming while it is sunny but not too sunny. We will not go when it is rainy, We will not go when it is like cold, or cold is there but it is not high, it is low. Then rain is raining, yes, obviously rain will be there, but raining will not be high, so still you can go for swimming, right? That means a water sport what you will be doing. Then similarly, if the climate changes from warm to cold, cold to warm, or else sunny to rainy, etc., these are the different target functions, or the boolean mean value functions, which will be representing the weather conditions. So weather conditions will change frequently. So early morning you will be having a what we can say is cold weather, but after the sunrise and sun will come down to some particular point of time, then it will be like more warm. So after it comes down to noon, from morning it will be, the condition will change from warm to hot, or it will be more sunny. So when it is going towards the evening, so then sunny will come down to again warm situation, then it will come down to again cloudy situation, right, and cool situation or cold situation, and so on. If it is rainy season, again you can say it is overcast condition will be there, or cloudy situation is there, or rainy it will be, and so on. So that can be represented in the form of a tabular format. So I will try to explain you using a tabular format. So for checking out the weather condition, we should represent them with respect to the sky, the air temperature, humidity, wind, water, and forecast, and you will say whether you need to go for the sport or not. Okay, now if you say sunny sky, and you will represent with the serial number 1, 2, 3, 4, then if you say sky is okay, fine, it is sunny, then you will check that air temperature is warm and humidity is normal, then wind is strong, again water is warm, and forecast is okay, same, right? So forecast means it is the prediction. So prediction will come based on the values which will be represented of the training examples of air temperature, humidity, wind, water, whatever you will take, and the same thing will be forecasting, right? The forecasted values will remain same, like sky is sunny, yes, air temperature is warm, humidity is normal, and wind is strong, and water is warm, and the forecast will say yes, it is the same. Now you need to check whether you are supposed to go for a water sport, that means swimming or not. So what is the outcome of it? Then you will say yes, I can go for swimming. Next, if you check with the second training set, then you will say again sky is sunny, then you can modify that later. Okay, then air temperature is again warm. Now humidity might be like little bit higher instead of normal, and wind will be say something like strong, and water will be warm since it is sunny. Then forecast will say yes, it is same. So sky will be sunny, air temperature is warm, humidity is little bit higher, still it is fine. Humidity is higher means yes, okay, fine. Wind will be strong and water is warm. Then the forecast will say yes, it is same. The forecast was saying that same, like sky will be sunny, warm air temperature, humidity will be high and wind will be strong, water will be warm. Then again the same thing what you will be doing is, yes, you will go with the sport. Obviously you will say yes. Next training set you can say like, if it is instead of sunny it is rainy. So instead of saying that sky is sunny, you will say sky is rainy, or the condition is rainy. Then what will be the air temperature? Then air temperature will be obviously cold. When it is rainy, air temperature will be cold. Then you will check with humidity. Humidity cannot be high, humidity will not be too high. But still, if you go with the coastal areas, if you are at coastal areas, then even though it is rainy and cold, humidity will be high in coastal areas, because it will be close to sea, you will be in coastal areas, sometimes humidity will be high. Next, what will be the status of the wind? So you can say that wind will be again stronger, but warm will be the water. So you can say that sky is rainy, air temperature is cold, humidity is high, wind is strong and water is warmer. The forecast will say yes, it is changed. Forecast was different and it has been changed, like, okay, forecast was like it will not be too rainy or too cold. These things were approximately correct, like it will, humidity is high, wind is strong and water will be warm. But the weather condition changed with respect to air temperature and sky, like it went to rainy and cold. So now the forecast has changed. So when the forecast has changed, then obviously we will think of going to the sport, whether you will be going for the swimming or not. Then you will say, no, I will not go for swimming today. Next you will go for another condition or training example. Say sky is sunny, air temperature is warm instead of cold and humidity is again high. And wind is strong, water is cool, the forecast will change. So probably forecast will be telling like water will be warm, but water has become cool. Now sky is sunny, then again air temperature is warm and humidity is high, wind is strong. Instead of warm, water should be warm, it has become cool or cold. So then again the forecast will say yes, it has been changed. But whether it is feasible that still you can go for swimming or not, that is you can go for water sport or not, yes, still you can go for doing a water sport. Now this is something called as concept learning, means the swimming or going for water sport is a concept, like at what condition you will go and do the swimming or you will go for a water sport. Now with the training examples, like it has to tell through your mobile phone, like, okay, yes, today you are supposed to go for a swimming or not, by checking the weather condition. How it will be cross checking with the weather condition is with respect to the sky, air temperature, humidity, wind, water and the forecast what it has been told with, or what the readings of forecast is given with. Now again sunny, warm, normal, strong and again warm of these features, then the forecast will be same, yes, you can go for the water sport. Whereas the third training set or the training example we will consider means it will be rainy, cold, high, strong and warm with respect to sky, air temperature, humidity, wind and water, and the forecast is changed, then obviously you will think of not going for the water sport on that particular day. That means you will not go for swimming. This is what is that concept learning will give you an idea of inferencing Boolean valued function for this training values based on the inputs and the outputs.